Sometimes when we have to deal with very large distances, we often have to write, so for instance, if I wanted to find how many centimeters there was in a kilometer, I would have to do, so let's say a kilometer would have to be times by 1,000 times by another 100. So that would be times 100,000. That's a lot of zeros and a lot of numbers. So if I had 1 kilometer, that's equal to 1 times 100 times by 1,000, which is obviously equal to 100,000 centimeters. Always make sure you don't lose your units, otherwise people might not know what you're talking about. So 1 kilometer is equal to 1, because that's the 1 part, times 100, okay, because that was going from meters to centimeters. 1,000, that's kilometers to meters. You could have written that in either way. But that's a lot of numbers. So often what scientists like to do, in what's called scientific notation, is to make this a little bit easier and a little bit quicker. 100, this one requires having to remember squares, the powers of, and what's called indices. You might vaguely remember this topic. Hopefully you'll remember that 10 times 10 is 100. Times tables, that'd be handy for you to know, just saying. Not that I want to be passé, but just saying. Well, this is the same, since it's multiplied by itself, this is the same as saying 10 squared. Like that. 10 squared is 100. That does not mean times 2. Please, for heavens to Betsy, just remember that that squared does not mean times 2. It does not mean times 2. Got that? Good. Love. Anyway, so this friend here, this 1,000, well that's 10 times 10 times 10. Because that's 10 times 10 is 100. 100 times 10 would be 1,000. So therefore, this would be the same as saying 10 cubed. Now, we can actually simplify this by saying 10 squared and 10 cubed, like that. Because 10 squared is 100, 10 cubed is 1,000, still equals to 100,000. Now, the wonderful thing about indices, 10 to the power of 5, we're same as 10 times 10 times 10 times 10 times 10. In other words, 10 times 10 is 100. 10 times 10 times 10 is 1,000. It's 100,000. What do you notice about 10 to the power of 5 and these two friends here? Well, the 10 to the 2 here, if I was to add the two indices, that would be the same as saying 10 to the power of 5. So in other words, if I add the indices, this is the same as saying 1 times 10 to the power of 5 centimeters. And I'll tell you what, a hell of a lot quicker than having to write 100,000. So there, 1 times 10 to the power of 5. So, let's try another example. 300,000 kilometers per second. So this is when we're talking about distances or speeds, for instance, that rockets would go, or various astronomical phenomena. So when you become an astronaut, remember this kind of thing. Remember that. Now, we want to write this in scientific notation. That was that whole indices business that we were talking about before. So if I want to write this, well, this would be the same as saying, so there's 3. 3 times what would get me 300,000? 3 times what gets me 300,000? 3 times 100,000. There are 5 zeros. So therefore, this would be the same as saying 3 times 10 to the power of 5 kilometers per second. So 3 times 10 to the power of 5. So we've got here light travels at 300,000 kilometers per second. So that's where that 300,000 come from. How far will it travel in a minute? Now, normally, you'd be thinking, okay, kilometers for every 1 second. So this would be no, let's not do that. That would be far too complicated. Well, for a start, let's get the first thing in scientific notation. And then what I'm going to do is I'm going to put the second, the 60s, because there's 60 seconds in a minute, also in scientific notation. Now, this 6 times 10 is 60. I'm just going to put a little 1 there to remind myself. Now, 3 times 6, well, I can now when I'm multiplying things, I can put them in any place, because 2 times 3 is the same as saying 3 times 2. Easy. So therefore, I'm going to write 3 times 6 times 10 to the power of 5 times 10 to the power of 1. So 3 times 6 is 18. 10 to the power of 5 times 10 to the power of 1 will be 10 to the power of 6. Now, what we now need to do, when we write in scientific notation, we don't usually like to have a 2-figure number like that. We don't put, like, for instance, 20 times 10 to the power of 3 is usually not scientific notation. It's usually 2 times 10 to the 3. It's usually only a unit. So what we can do here is, if I was to make that 18 would be the same as saying 1.8 times 10 times 10 to the power of 6. Yeah? Now, I know that might be a little bit weird. Why have I done that? Okay? So when you do scientific notation, it needs to just be like one figure, 1 unit. So it needs to be 2 to, like before we had 3 times 10 to the power of 5. So therefore this needs to be 1.8 times 10 to the something. Okay? So whenever you're doing scientific notation, it can't be like 12 times 10 to the whatever. It needs to be 1 point something something or 2 point something 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 times 10. So 18 is the same as saying 1.8 times 10. So 1.8 times 10 gets me 18. So that would be 10 to the power of 1. So 10 to the power of 1 times 10 to the power of 6. 1.8 times 10 to the power of 7. It'll travel 1.8 times 10 to the power of 7 kilometers in 1 minute. When you're answering a question, don't forget to actually remember to include the question in there. So it's asked, how far will it travel in a minute? Make sure your answer also includes that as well.